Alright, so here we are at Cosmo Caixa, the Barcelona Science Center, and we're checking out a really crazy thing right here. Looks pretty boring, but let's see if we can get some details. Oh, there's one. See that? Let's see if we can find another one. Oh, there's one. Went away. So apparently what these things are, there's a special liquid in here that is what? Is
detecting cosmic rays.
Is detecting cosmic rays. So there are these particles that fly out of the sun and collide with atmospheric particles, so little molecules in the atmosphere, and these create a whole cascade of secondary particles that sort of fly down and are going through us every minute and through everything else, but because they're so small we don't even notice them. But this particular liquid is susceptible to them, and so when they hit it, they react and create a little trail, and there's one there. So these are subatomic particles, single particle collisions that we're seeing with our very eyes. Isn't that amazing, Carmen?
Yeah, it's pretty amazing.
It's pretty amazing.
Shooting through my head.
Shooting through Carmen's...
Constantly, all the time. It might explain a thing or two about me.
Yeah. And what else is cool about this, Carmen?
That it actually doesn't affect human beings or other beings.
Yeah.
The fact that you have trillions of neutrinos shooting through you every second, and our bodies aren't affected by it.
Yeah.
Like, what is it that these tiny little things don't actually affect us? That's my question.
Yeah. So those are neutrinos. These things here, what are they called again?
Muons.
Muons.
These are muons. These are not neutrinos, because neutrinos are not detectable.
They are, but they're really, really hard to find. You need huge tubs of special liquid like this to do it. So
only crazy scientists.
Yeah. Another crazy thing about this is that these particles, these secondary particles, when they get created in the atmosphere, their lifetime is only like a trillionth of a second or something really, really small. And even though they're going really fast, because they would decay or disappear in such a short time, they wouldn't have time to actually get from the atmosphere, so way up in the sky, down to the surface of the Earth where we are now. There's one. Oh, there's two. So we didn't really expect to see these down here, but once again Einstein comes into the picture and says that because these things are going really, really fast compared to us, the time frame that they experience is much slower than ours. Alright, here we are with Carmen, and this is a cosmic rays tutorial. So what are cosmic rays? Hey, look at that person. It could be you, it could be us, it could be anybody on this planet. So there are these crazy particles that are flying through space all the time, every second of every day, and we don't even know they're there because they're really small and they go right through us and through everything else pretty much, except for some things, which we'll see in just a minute. But okay,
they go trillions of them.
Trillions of them. Yes.
Through your brain a second.
That might not be true, but it's interesting.
Something like that.
Okay, so we have these cosmic rays, and they come from the sun. So there are particles that come from the sun, but then these particles hit other particles in our atmosphere. So there's the sun over here and goes through space, and this is our atmosphere. So this is like the air and stuff above us, and they hit the molecules in our atmosphere and then create all these secondary particles. It's like a big rock hitting another big rock, and then they both sort of crack and pieces come flying out. So these pieces are what fly through us every second. And what's crazy about them is that they actually don't live for very long. So if you were to create one, it would cease to exist after about a trillionth of a second. That might not be true either, but just to give you some idea, really, really short. And even though they go really fast, they probably wouldn't have the time to get from the atmosphere up above us in the sky to where we are here. But we see them here. So why is that true? And it's because of Einstein, of course. He always comes into the picture. And turns out, with his crazy hair and chalkboard and such, Einstein's theory predicts that time passes slower in the reference frame of objects that are going really, really fast compared to someone who's watching them go by. So us, sitting here as passive observers watching things fly by. So these particles that fly down from space, they know how long they should live, and they just sort of appear and live for as long as they know they should, and then cease to exist. But because their time is passing slower, because they're going really fast, to us, they actually do have enough time to cover the distance from the atmosphere to the surface. So let's check it out. So there's some crazy liquid in here, and it's when these particles come flying down, you actually get to see a reaction taking place in the liquid that they go through. So what you're seeing right now is an experimental verification of Einstein's theory of relativity. Let's see if we can spot some big ones. Oh, there was a little one. Let's see. Oh, there's a small one. So these things are called muons. Oh, there's a nice long one. So these are single particle events. Isn't that crazy? There's another one. And are only observable because of Einstein's theory of relativity. Now if that's not crazy, I don't know what is.